chain of events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. This episode is brought to you by Manytrix, makers of helpful apps for the Mac. Visit manytrix.com/pragmatic for more information about their amazingly useful apps. We'll talk more about them during the show. Causality is also supported by you, our listeners. If you'd like to support the show, you can by supporting our sponsor or by becoming a patron. Patrons have access to early release, high-quality, ad-free episodes, as well as other bonus material. You can do this via Patreon. Just visit engineer.network/causality to learn how you can help this show to continue to be made. Thank you. Thunder River Rapids. Dreamworld is an amusement park in the suburb of Coomera, on the outskirts of the Gold Coast in Queensland, Australia. Originally developed by John Longhurst, who bought 85 hectares of land there in 1974, construction of Dreamworld began later that year. It was opened to the public on the 15th of December 1981, just in time for Christmas that year. Whilst not the first theme park in Australia, it expanded over the years to become the largest in Australia, with a mixture of mild to extreme thrill rides, wildlife exhibits, and themed attractions. The Thunder River Rapids ride was opened on the 11th of December 1986 and remained the only operational ride of its class in Australia until 2016. It was based on the Thunder River attraction, originally designed by Bill Crandall, the general manager of Astroworld in Houston, the United States, designed by Intamin in 1979, a Swedish company, and first opened in 1980. However, the design and construction of the Thunder River Rapids was managed in-house by Dreamworld, though the detailed design was done by an external contractor. The ride was one of the most popular in the park, with queues extending over 2 hours long during summer, as it was advertised as a truly family-friendly ride with only a moderate thrill rating. The ride had a top speed of 45 kilometers per hour, or 28 miles per hour, at its fastest point, with a minimum age restriction of 2 years old, with no height restriction except that children under 4 years old, or 120 centimeters, that's 4 feet in height, needed to be accompanied by someone 14 years or older. The ride consisted of multiple free-floating round rafts with equally spaced inward-facing seats that could carry 6 passengers per raft, with an option for up to 3 small children to be seated in their parents' laps. A loose Velcro seatbelt could be applied, with a holding bar in the center circle that patrons could grab onto for additional support during the ride. The ride launched from at near its maximum height, with the raft floating downhill along approximately 400 meters of channels, into and out of tunnels and various rapids, providing a bumpy ride with passengers getting wet to varying degrees along the way. A complete circuit was approximately 450 meters long and took 4 minutes and 10 seconds for an average cycle, which included 42 seconds on the lift conveyor at the end of the ride that returned the rafts to their starting position. In 1999, the park was purchased by the Macquarie Leisure Trust, changing their name to Ardent Leisure Group in 2009. The park had expanded with new attractions gradually through the years. However, despite its age, the Thunder River Rapids remained extremely popular. Let's talk about the incident itself. On the 25th of October, 2016, at approximately 2 p.m. local time, the ride operator released a fully loaded raft number 6, carrying Stephen Anthorpe, Bree Dedini, Arlen Anthorpe, Chase Anthorpe, Ms. Michelle Farrer, and Dakota Marks. The ride was operating with 2 operators and 9 rafts in circulation. At approximately 2:01 p.m., a fully loaded raft number 5 carried Kate Goodchild, a 32-year-old mother of 2, Ebony Goodchild, Kate's 12-year-old daughter, Luke Dorset, Kate's 35-year-old brother, Rusba Aragi, a 38-year-old partner of Luke, Cindy Lowe, 42-year-old mother of 2, and Kieran Lowe, 10-year-old son of Cindy. Kate, Ebony, Luke, and Rusba were up from Canberra for a wedding. Cindy and Kieran had travelled from Sydney. Due to age restrictions, David Turner, it's Kate's husband, with he and Kate's 8-month-old daughter, Evie, stood by to watch. Earlier on, Matthew and Isla Lowe, Matthew and Cindy's daughter, also decided not to ride. At 2:03 p.m. and 35 seconds, Raft 6 was picked up by the final lift conveyor without incident. At 2:03 p.m. and 50 seconds, camera 14 of the closed-circuit television system captured the moment that the south pump stopped running. For the ride to operate normally, both the north and south water pumps were required to lift water from the reservoir to the top of the ride. With that pump tripped, the water level in the landing area began to drop, dropping some 200 millimeters within 15 seconds of the pump tripping and 400 millimeters total within a minute of tripping. At 2:04 p.m. and 10 seconds, raft number 6 had descended the conveyor belt into the landing area in the top channel of the ride. However, with the significantly lower water level, it became stranded on the support rails. The support rails were installed in the bottom of the channel to stop the rafts from hitting the bottom of the channel when water levels were too low. The raft successfully traveled around the circuit until reaching the final lift conveyor, and at 2:04 p.m. and 22 seconds, raft number 5 was picked up by the conveyor. At 2:04 p.m. and 50 seconds, raft number 5 reached the top of the conveyor and began to descend towards the landing area in the top channel. The operator at the control panel saw the raft approaching at that point and stated that they pressed the red stop button multiple times, estimating there was 5 to 10 meters between the stationary raft number 6 and the approaching raft number 5. The conveyor, however, did not stop at that time and continued to push raft number 5 forward. At 2:05 p.m. and 3 seconds, raft number 5 collided with raft number 6. There were 3 individual impacts as each raft shifted position with each subsequent impact. Raft number 6 sliding along the support rails until it caught on a cross member, with raft number 5 gradually having its leading edge pushed upwards, eventually sliding it over the top of raft 6. 4 seconds later, the conveyor had driven raft 5 into a vertical position, with the conveyor's leading edge now driving the top of the rear seatbacks down into the water, with the underside of the raft pressed against the stranded raft number 6. A few seconds later, both Ebony Goodchild and Luke Dorset fell from their seats in raft 5 and fell into the still-moving conveyor planks, drive axle and cog mechanism of the conveyor system. Cindy Lowe and Ruspa Araki were seated at the rear of the raft and were caught within the conveyor belt mechanism as the raft was inverted and were pulled into the plank and cog mechanism as it continued to operate. At 2:05 p.m. and 14 seconds, the conveyor belt finally began to slow down and 5 seconds later came to a stop. Ebony Turner and Kieran Lowe climbed out of raft number 5. Stephen Anthorpe, who was in raft number 6, assisted his family out of that raft and immediately re-entered the scene via the conveyor belt, attempting to assist Ms. Goodchild. Danny Haber, who was waiting in line, also entered the scene to assist, and Stephen Anthorpe commenced CPR on Ms. Goodchild. Shortly afterward, they were joined by the theme park's first aid officers to take over attempts to resuscitate her. By 2:17 p.m., only Ms. Goodchild and Mr. Dorset had been located, with Cindy Lowe and Ruspa Aragi still trapped in the wreckage. At 2:22 p.m., the Queensland Ambulance Services arrived, and despite their best efforts, Cindy Lowe, Ruspa Araki, Goodchild, and Luke Dorset were all pronounced dead at the scene. They had died as a result of severe physical trauma. There was no evidence of drowning. During the investigation, many attempts were made to recreate the accident using test dummies, loaded and unloaded raft combinations, and with rafts of different levels of inflation. However, the investigators were unable to replicate the inversion observed on the day of the incident. On some test runs, it was noted that slats in the conveyor that bowed outwards were far more likely to catch on the flotation ring of the rafts under test. However, none actually tipped during many repeated attempts. The ride relied on water movement due to gravity to propel the rafts through the course. To achieve this, there were 2 pumps, called the north and south pumps. Each pump was gravity-fed from a storage reservoir before pumping that stored water out through 2 outlets positioned under the conveyor belt at the top of the ride. Each pump had 4,000 litres per second flow rate capacity and was each driven by a Danfoss VLT Aqua 8502 variable speed drive. These pumps alone were so large they represented nearly 1/3 of the power consumption of the entire Dreamworld theme park's electricity. The initial water flow started at the load and unload areas before flowing down through the trough system around the course. The two outlets are 1.6 meters in diameter and approximately 3 meters from the bottom of the pit. The pipes were also utilized in a reverse flow manner when water was being drained from the ride area, which caused the water level to drop quickly and considerably when the pumps stopped for any reason. The drives were about 10 years old and had recorded no faults on the northern drive, but 8 on the southern drive, of which 6 were earth faults. Danfoss error code number 14, of which 3 of those earth faults had occurred the day of the incident in a 2-hour period. During the investigation, they isolated the motor from the drive cables and measured the windings, and Danfoss were called to site test their variable speed drive, but neither found any issues with the drive or the motor. As a quick note, measuring is simply a method of applying a voltage between a conductor and another section you're trying to test if there is significant resistance between the two, usually between the cable conductor and an insulator or another part of the equipment that it's supposed to be insulated from. From experience, the worst kind of fault to track down is an intermittent fault. In this case, the inquiry found no definitive cause. However, in my experience with water pumps and VSDs, they can be set off by corrosion on earth wiring, vermin damage to cable insulation, and water ingress into junction boxes. There's so many ways you can get an earth fault. The earth fault is designed to protect the user from an electric shock. However, they can be a bit tricky to track down. Scott Ritchie was the electrical general manager in the park's engineering and technical department, and his assessment of the recurring earth fault was that it was an inconvenient and intermittent issue, which did not pose any risk to guests or to the ride's safety. During the investigation, Mr. Ritchie acknowledged that he had consciously made a decision that the intermittent fault would not be a danger as long as the operating procedures were followed. On the 19th of October 2016 at 11:20 a.m., 6 days before the incident occurred, the south pump had tripped on an earth fault, and Scott Ritchie called the drive guys, as they were known, meaning Applied Electro. Applied Electro were a Danfoss service agent that Dreamworld used for drive maintenance and repair support, and scheduled a technician to attend site on the 27th of October 2016, as Scott Ritchie had set the priority as urgent but not critical, saying, and I quote, "We are back up and running now. However, the sooner you are able to get to site, the better," end quote. The 27th was the earliest a technician could attend a call of that urgency, and unfortunately, this was to be after the day of the incident. A subsequent earth fault trip on the 22nd of October and again on the 23rd were both reset, and the ride went back into operation each time, with no further troubleshooting performed, as the drive guys would be attending in a few days to investigate in more depth. The morning of the incident, there were 2 more earth trips, at 11:50 a.m. and again at 1:09 p.m. before the ultimate trip that would lead to the incident. Each time the fault was reset and the ride was returned to operation. The real question is, with 2 trips so close together and 2 ride shutdowns that very day, was it safe to operate the ride until the cause could be definitively determined? Dreamworld's own breakdown procedure, Part 5, stipulated that, and I quote, "If there is a repeat of the fault within the next 24 hours, do not attempt to rectify the fault until the engineering supervisor has been notified and given authority to rectify the problem," end quote. However, the operators at the Thunder River Rapids on the day were unaware of this requirement, and feeling pressure from disgruntled guests, simply reset the second fault and proceeded to operate the ride following the second trip. Having said that, and given Dreamworld's historical reactions to similar situations, it is highly likely that had the operators sought permission to restart the drive from the engineering supervisor following the second trip that day, it would still have resulted in approval to reset and continue, although we can never be completely certain of that outcome. During the investigation, it was revealed that design details for the Thunder River Rapids as a whole were rather thin. The records of the original design by Dreamworld of the Thunder River Rapids was very light on detail, and despite multiple requests, Ardent Leisure never produced circuit diagrams, critical component lists, or risk assessments relating to the Thunder River Rapids ride. In 2015, a safety risk assessment was performed by the Dreamworld Safety Department of the Thunder River Rapids ride. It wasn't focused on the whole ride, but rather at the entry to the conveyor at the low point of the ride, that's at the bottom of the incline. Concerns related more to conveyor rollback and slippage, and the scope was then focused on chain brake and detecting the presence of a raft at the bottom of the conveyor. It was noted that in a future stage, the new PLC, Programmable Logic Controller, could also be adapted to control and monitor the pumping systems along with the arrival and dispatch gates. It was proposed during this upgrade to extend the scope of work to include an upgrade of the main control panel. However, the additional delay and cost of extending the scope was decided as being too much of a delay to the priority work at the bottom of the conveyor. As the scope for the upgrade was let to Products for Industry, PFI, and Sage Automation, with PFI being the successful tenderer for the work. The scope did include a Stage 2 option to add a pump interlock. However, this was not executed as it was not considered a priority concern nor a safety issue. The upgrade began on the 8th of February 2016 and took a week to complete, test, and return to service. Mr. George Rutherford, Technical Director of Projects Etc. Proprietary Limited, provided technical expert testimony during the investigation and stated, and I quote, "The lack of a suitable safety-rated water-level detective system interfaced to the upgraded conveyor system. Such a safety system could easily have been provided and at a minimal cost." End quote. The conveyor control system retrofit had installed a SIL 3 rated controller in 2016. It was an ABB Pluto D45 safety PLC. However, its focus was on conveyor slippage and chain brake detection. In 2017, Mr. Rutherford added that it would have cost an additional $3,000 Australian to add redundant level sensors into the conveyor safety PLC. That would include wiring, materials, programming, and testing, had it been done at the same time as the conveyor PLC was fitted in February 2016. Unfortunately, it wasn't considered at that time, and the conveyor controller was completely independent of the main control system that controlled the pumps. The main control system PLC was found not to be fail-safe in design. It was described as a rat's nest of wiring modifications and repairs over the years, with multiple single points of failure, and a lack of fail-safe wiring meant the failure of the emergency stop functionality would be completely undetected until a demand was placed on the system. Before we go any further, I'd like to talk about our sponsor for this episode, and that's Manytricks, makers of helpful apps for the Mac, whose apps do, well, you guessed it, many tricks. Their apps include Butler, Keymao, Leech, Desktop Curtain, TimeSync, Moom, NameMangler, Resolutionator, Witch, and the return of Usher with Usher 2. There's so much to talk about for each app they make, so we're going to touch on some of the highlights for 6 of them. Let's start with Usher 2. The return of the classic Usher, but now it's a full 64-bit app that works well with Catalina and Mac OS 11 Big Sur. So what is Usher? It's an amazing, powerful media management and playback app that can see movies you have in TV, music, and Photos apps, or any library location that you'd prefer on your Mac. It can organize them for you. If you like, you can create advanced playlists and sorting criteria, and you can even edit their information, all from within Usher. Not only that, to celebrate the return of Usher, you can grab the Usher 2 beta from the link in the show notes, and there's a special pre-sale just for it as well. Check it out. TimeSync. Track your time spent in apps or activities on your Mac the simple and easy way with TimeSync. You can pool your apps by common activities, create custom trackers for non-Mac activities, and its simple but powerful reporting feature shows you exactly where your time went so you can plan better and stay focused. Resolutionator is so simple. It's a drop-down menu from the menu bar, and you can change the resolution of whatever display you like that's currently connected to your Mac. The best part, though, you can even set your resolution to fit more pixels than are actually there. It's very handy when you're stuck on your laptop and you need more screen real estate. Witch. You should think about Witch as a supercharger for your Command Tab app switcher. If you've got 3 or 4 documents open at once in any one app, then Witch's beautifully simple pop-up lets you pick exactly the one you're looking for. You can switch between tabs as well as apps and app windows with horizontal, vertical, or menu bar switching panels. With text search as well for switching, you can show the frontmost app in the menu bar icon. It has full touch bar support and much, much more. It's great. NameMangler. You've got a whole bunch of files that you want to rename quickly, efficiently, and in really large numbers. Then NameMangler can help. It's designed for staged renaming sequences using powerful regex pattern matching. And recent additions include a group by feature when making a sequence, and title case conversions can now keep their existing formatting or convert them all to lowercase based on their word length. The best part is it shows you the result as you go. And if you mess anything up, just revert back to where you started and try again. Moom. makes it easy to move any of your windows to whatever screen positions that you want. Halves, corners, edges, fractions of the screen, wherever on the screen, and then you can even save and recall your favorite window arrangements with a special auto arrange feature when you connect or disconnect an external display. It has full touch bar support and keyboard integration with Adobe's apps, and it also works perfectly on an iPad operating in sidecar mode, and has a sharper hexagonic look in Big Sur. It's the first app that I load on a new Mac because it's just awesome. Now, that's just 6 of their great apps, and that's really only about half of them, and they work with the latest version of macOS Big Sur. All of these apps have free trials that you can download from Manytricks or oneword.com/pragmatic, and you can easily try them out before you buy them. They're all available from their website or through the Mac App Store. However, if you visit that URL, you can take advantage of a special discount off their very helpful apps exclusively for Engineer Network listeners. Simply use Engineer25, that's Engineer the word and 25 the numbers, in the discount code box in the shopping cart, and you'll receive 25% off. Now, this offer is only available to Engineer Network listeners for a limited time, so take advantage of it while you can. Thank you once again to Manytricks for sponsoring the Engineered Network. So what exactly went wrong? There's 3 aspects I'd like to focus on. Certainly there are a lot more. There are always a lot more, but I'd like to focus on those that are most easily avoidable in design and in operation. The first 2 relate to the design of the ride, the hydraulics and then the emergency stops, and the third to the operator being used as a control system instrument. So let's start talking about the hydraulics. The primary cause of the incident was the tripping of the southern pump, which led to a drop in the water level in the landing area. Now, during testing, it was found that it was impossible to operate the ride unless both pumps were running at the same time. So, simplistically speaking, if you want to run safely and reliably, then you should have a third pump in case one of the other 2 pumps fails for some reason. Well, they didn't. The conveyor wasn't interlocked against low water level in the landing area. Why not? If you run the conveyor and a raft launches off the end into an empty channel, you're going to do some damage to the raft and the people in it. Level sensors are simple and they're cheap in relative terms. Some sensors, depending on the ones you pick, can get gunked up and need cleaning regularly, sometimes, for them to be accurate. But the good old-fashioned float switch works really well. It's pretty simple. It's a small rubber ball with a mercury level switch in it. When the tank is empty, the ball hangs vertically, the mercury flows away from the 2 electrodes and tells you there's insufficient water to run the conveyor. When the water level's high enough, the ball floats on its side, the mercury flows down and makes an electrical circuit between electrodes, and you know it's safe to run the conveyor. When we do machine safety design, we look at how energy is being input into the system and how to safely stop that energy from performing work on the system under a safety shutdown scenario. In this context, the 2 devices putting energy into the system were the water pumps and the conveyor. If there's a problem and we need to stop the conveyor, is there any circumstance where stopping the conveyor creates a hazard? Well, no, not really. If we stop the pumps, does that create a hazard? Well, if we consider the rafts in isolation, then you might say no, it doesn't. It drains the water from the channel through backflow, back down the inlet pipe to the reservoir, and the rafts simply sink to the bottom or onto the support rails where they're fitted. But if you couple that with the conveyor still putting energy into the system, then stopping the pumps with the conveyor running does create a hazard, as was the case in this incident. Normally, if we identified this during design, we'd conditionally trip the conveyor if either of the pumps tripped. Failing that, we'd use an emergency stop to stop everything. In this system, the emergency stop buttons for the conveyor were independent of the main control panel, and they were fitted at the second operator's operating position, which was called the unloading section. When they're pressed, they would stop the conveyor in about 8 seconds fully loaded. In this incident, the conveyor emergency stops were not pressed at all, but the conveyor stop button ultimately was pressed, just following the impact, and brought the conveyor to a slow stop, approximately 11 seconds after the rafts had collided and the button had been pushed. And finally, using a human as a level sensor. The operation of the system relied on an operator acting as a level sensor. The operators were told to visually glance at the scum mark on the side of the channel that had been created over decades of use, which became their de facto normal operating level marker on the channel water level. If the water was about that high, you're okay. Seriously? They didn't even have an intentionally marked water level. There was no gauge, nothing, just a scum line. Since the pump tripping was such a big deal, you might think there would be some kind of alarm for the operator, to inform them that it had tripped for some reason. Well, there was a current meter and a running light on the control panel, but you could only see them when you were at the control panel, of which there was only one panel, and the primary operator would be loading passengers onto the next raft and was away from that operating panel for 45 seconds at a time. There was no audible alarm, no light stack, no radio notification, nothing like that at all. I remember when I went on this ride, it wasn't quiet in that loading area with the pumps running. People were talking, water was flowing over the rapids, was all very noisy. During the investigation, they found there was no discernible change in environmental noise when one pump had tripped. So the only way an operator would know if they weren't at that control panel would be visually checking the channel level and looking at the scum line. The ride was designed and constructed in an era where automation was expensive, and there weren't as many theme park rides in the world, and operators were expected to keep an eye on everything. Some might say the ride operated for nearly 30 years without an incident like this, and operator attention worked fine. Well, except that's not really true. In 2014, in what was referred to as the bus incident, named after the primary operator at the time, a backup air compressor had shut down, and within 10 minutes, the low air pressure alarm sounded. During his attempts to secure the rafts that were in circulation, the operator unintentionally shut down one of the two pumps, leading to a drop in water level in the landing channel. This led to a raft becoming beached on the support rails in the landing area in exactly the same position as would eventually happen again in 2016. When a second raft came up and over the conveyor, Mr. Buss, who was the operator at the time, stopped the conveyor as the second raft contacted the first. In this incident, realizing his mistake with stopping one of the pumps, the operator quickly restarted the pump, freed the raft in the landing area, and restarted the conveyor. During this time, another raft had managed to drift into the reservoir area where rafts weren't really meant to go, and although this was recovered without any injury to any guests. Interestingly, the investigation into this incident by Dreamworld internally was that it was a result of operator error and not following correct ride operating procedures. Mr. Buss's employment was terminated as a direct result of the incident. He was one of the most experienced operators at the park at the time, with many years operating the Thunder River Rapids. He described operating the ride as more difficult than the other rides, as there were a lot of tasks to be undertaken simultaneously. There was no offer for retraining, nor was any refresher training done for the remaining ride operators following the incident and his termination. In addition, no design modifications were made as a result of this incident, nor were any learnings applied in the following year's safety risk assessment. In fact, it appears not to have been considered in the risk assessment at all. The problem with relying on a human to check something to ensure that it's safe is that people get tired. They get distracted. They need training. They need retraining. And they have good days and bad days and so on. And this is why automation is done for important things like checking the water level. Let's talk about the lift conveyor modifications. As an aside, I personally noticed the number of slats had been reduced over the years that I went on this ride, and I wondered why. The main lift hill consisted of a conveyor with 2 drive chains and many interconnecting wooden slats that took the weight of the rafts. Gravity and friction kept the rafts in place as they were pulled up the hill, and gaps between the slats allowed water to drain from underneath the ride, reducing the mass required to be lifted, but also reducing the potential for the raft to slip backwards down the belt. Original construction photos from 1985 clearly show a regular spacing of slats on the ride of approximately 300 millimeters. As part of ride modifications prior to 2008, every other set of slats was removed, making the spacing a full 750 millimeters between slats. The investigation found that they were removed in an attempt to reduce the mass of the conveyor that had been leading to chain stretching and stress on the conveyor overall. There was also mention of a time period where the weight of all of the slats on the conveyor was thought to be causing regular conveyor motor trips on thermal overload. Mr. David Flatman, Principal Workplace Health and Safety Advisor, Mechanical of the Engineering Service Unit, stated in his expert advice that the gaps between the slats was a contributing factor to the conveyor grabbing on the flotation ring that led to the flip of raft in this incident. Had all of the slats in the original design still remained, a significant incident could still have occurred, though a raft flipping in the manner that occurred in 2016 would have been significantly less likely. Due to a lack of detailed records, the investigators could not determine who authorized their removal or when they were removed, though best estimates, based solely on personal interviews, both past and present, was that every second and third slat had been removed sometime between 1988 and 1990. During the investigation, it was found that there was a similar incident that occurred in 2001. Melinda Lind was the lead operator on the morning of the 18th of January 2001 and commenced the startup procedure at approximately 9:17 a.m. that day. She released the rafts to run a full cycle prior to opening the ride to guests. At 9:30 a.m., the second operator, Joe Stenning, arrived and began opening the queue for guests. Distracted by a conversation with guests in the growing line, Ms. Lind did not notice that 2 rafts had become stationary at the unloading area, with a further 3 on the conveyor moving towards the landing area. For reasons unclear, neither operator released the rafts in the unloading area, nor did they stop the conveyor, and as the 3 rafts came off the conveyor, they collided with the rearmost of the 2 stationary rafts, causing one to flip. Following a conveyor shutdown and clearing of the area of guests, they had considerable difficulty in clearing the rafts from the area. A subsequent report into this incident identified it as a dangerous event. However, no one was injured and found 4 contributing factors, all relating to the operator's lack of communication, distraction, and tardiness. Following the incident, Melissa Lind was reassigned to the food and beverage section of the park and shortly thereafter resigned from Dreamworld. There was no evidence of refresher training, scenario-based training, engineering design review, or any kind of detailed investigation into this incident. Indeed, years later, during this investigation into this specific incident, several key members of staff interviewed were completely unaware that this incident had ever occurred. Let's talk about the aftermath. On the 9th of November 2016, Deborah Thomas, CEO of Ardent Leisure, announced that the Thunder River Rapids ride would be permanently closed and demolished, and a memorial would be built in its place. The park closure period cost the amusement park $300,000 Australian dollars every day, and on reopening, attendance was minimal, and it has yet to return to anything near the pre-accident volumes. Dreamworld remained closed nearly 6 weeks following the incident, and by the end of January 2017, all but 3 rides were back in operation after extremely strict safety inspections were performed on all park attractions. Pitt and Sherry Operations Proprietary Limited recommended multiple retrofits to other rides at the park, and this indirectly triggered further inspections to nearby theme parks including Movie World, Wet n Wild, and SeaWorld on the Gold Coast alone, under the direction of the Queensland Employment and Industrial Relations Minister, Grace Grace. Ardent Leisure were fined $3.6 million Australian dollars over the incident on the 25th of September 2020, with 3 counts of failure to comply with health and safety duty, Category 2, under the Queensland Health and Safety Act. In July 2020, a contingent of its own shareholders launched a class action lawsuit against Ardent Leisure over the incident. Craig Davidson, the CEO of Dreamworld, resigned on Friday the 29th of June 2018. In 2018, Ardent Leisure collectively handed out $1.8 million in termination payments for executives departing the company, as Ardent still posted a collective loss of $88.6 million Australian dollars. Since then, investment has been poured into new attractions, including a $30 million roller coaster still under construction, now even further delayed by the COVID-19 pandemic. This incident is more real to me. For most episodes of this show, I'm not involved or touched by the incident in question beyond my professional desire to learn from the mistakes of others, try and educate as many as I can about what to look out for, and to hopefully prevent future incidents from occurring. But in this case, it's very different. I rode on this ride, not just once, but many, many times. I first visited Dreamworld when I was 17 years old with a friend's family, and in 1993, I first went on the Thunder River Rapids that day. Since then, a lot's happened. I got married, had kids, and I've taken my entire family on this ride. We'd get there to Dreamworld when the park opened, and we'd run to be the first in line for the Thunder River Rapids because the queues were always so long because everyone loved that ride. The kids still talk about it sometimes, even today. I live an hour and 15 minutes away from Dreamworld. In preparation for this episode, I referred not only to media footage and the official coroner's report, but my own personal photo and video libraries that I'd taken myself when the ride was operational. It really, honestly, could have been me and my entire family that were killed, and that's not an exaggeration. We had season passes for Dreamworld and the adjacent Whitewater World just that previous year, and we went all the time. And we loved that ride because it was the only ride in the park where we could all go on together at once as a family. I remember being next in line for a raft once on Thunder River Rapids, and I watched the ride break down right in front of us, and then being told, sorry, we need to close the ride. So I know it had old ride issues, and despite my potentially strange view of the world, even I never really considered what happened on that day to be a possibility. I do remember looking at the control panel and wondering how old it was because it looked a little bit ragged. It just feels so very real and very strange to me. And in case you're interested, we haven't been back. So what do we conclude from all of this? Clearly, the actions of Dreamworld in handling the fallout of the incidents that led up to this incident on the Thunder River Rapids, they were centered around punishment and dismissal, and there was very little shared learning passed down. There was no retraining offered to those that were implicated, or, importantly, to the ones that weren't implicated either. Either way, there didn't seem to be a safety learning culture, or any kind of documented change management system, or detailed design drawings and specifications were inconsistent between the rides in operation and barely existed for Thunder River Rapids. Clearly, there was some interest in reinvesting in the ride to improve its safety, but because it was based on an incomplete historical picture and it wasn't an independent end-to-end assessment, it missed the key risk that led to this incident. When we go to an amusement park, we put our trust that their rides will thrill and excite us, but in a safe way. It's a safe space to play. It's a safe place to have fun. When we're designing machine safety systems, you have to make sure you think through how to safely stop it. And remember that when the pressure is on, in the heat of the moment, you have to make it as easy as possible for the operator to just hit a big red damn button to stop it and make it safe. I've recently been to theme parks in southeast Queensland, and there have been significant improvements. Retrofitting of actual scales to check people's weight at Wet n Wild to make sure that when they go on rides, they are the correct weight so that they don't fly off, because people lie about their weight. Little things like that, more prominent emergency stops. But these are lessons that have all been learnt before. Hopefully we don't need to keep learning them. I'd personally like to thank Manytricks for sponsoring the Engineered Network. If you're looking for some Mac software that can do many tricks, remember to specifically visit this URL, manytricks, or one word, .com/pragmatic, for more information about their amazingly useful apps. If you're enjoying Causality and want to support the show, you can by supporting our sponsor or by becoming a patron. You can find details at engineered.network/causality to learn about how you can help this show to continue to be made. A big thank you to all of our patrons. A special thank you to our silver producers, Mitch Bilger, John Whitlow, Kevin Kosh, Oliver Steele, Leslie Law Chan, Havthor, and Shane O'Neill, with a special thank you to our gold producer, known only as R, Causality is heavily researched, and links to all the materials used for the creation of this episode are contained in our show notes, and you can find them in the text of the episode description of your podcast player or on our website. You can follow me on the Fediverse at Chidgey at engineered.space, on Twitter at John Chidgey, all one word, or the network at engineered_net. This was Causality. I'm John Chidgey. Thank you so much for listening.